So before we start talking about set 26 and new stuff, let's check this so you can see how you did. Okay, so I'm going to be grading how you show your work, right? Whether you cancel things, whether you get it down to 1 times the variable, all that kind of stuff. So right here, what'd you do?
Minus the 5.
So on both sides?
Yeah.
Okay.
I put the big line.
Okay, so 4x equals 32? 32? And then, now when we divide by 4, we just use that divide symbol right there, correct?
Yeah.
Did you cancel those?
Yep.
So x equals 8? Does that number work? Does 4 times 8 plus 5 equal 37?
Yes.
You can check your work, can't you? You can see whether it's correct or not. Okay, over here, what first?
Plus the 4.
Add 4 to both sides?
Yes.
You notice how I always say to both sides and you don't?
Yeah.
Anyway, let's add 4 to both sides of the equation so we keep it equal. So that adds up to 0. And we get 2 times a equals 14.
Divide by
Both
2 on
sides.
both sides.
Divide both sides by 2. And this cancels and gives us 1 times a equals 7. So these canceling, they're 0, correct? They're gone. These canceling, divide out and give us 1. See how different that is? Just knowing that is going to help you a lot, okay? All right, over here. I did this one. Now we did a couple like this, haven't we, together? And it's kind of a little tricky, but we need to subtract 5. That's correct. The negative is for the opposite of p here. The 5 is a positive, isn't it? We need to subtract 5 in order to get rid of that. So we end up with 3 equals the opposite of p.
And then divided both by like 1, like negative 1.
By negative 1, right. Now, you might just look at this and say, well, you know, if 3 equals the opposite of p, then doesn't p have to equal the opposite of 3? What do you think? Can you kind of see that? Now, if you think of this as a negative 1, and you think, well, I want that to be a positive 1, if I divide both sides by negative 1, that'll make it positive 1. Okay, but that also makes this negative. So, I don't always show my work like that. A lot of times I'll get an answer where I'll get, you know, the opposite of y equals negative 10. So what do I immediately know?
Y equals 10.
Y equals 10. You know, if I get the opposite of x equals 4, then 4 must equal what?
Negative 4.
Negative 4. So we don't always show this bit right here. Okay, and then finally over here, add 1. These add up to 0, right?
21.
So 21 equals negative 7 times p. Now what do I have to divide by?
7.
Negative. What happens if I divide by positive 7?
And you'll get
The answer would be wrong.
Yeah, it's not against the rules, but it would give me what negative p is equal to, wouldn't it? Okay, so we've got to divide both sides by negative 7 so that this gives us positive 1 times p equals negative 3. Now, I guess if you did divide by 7 and you got 3 equals the opposite of p, could you get to here? Right, but you might as well do it in one step, right? Now, I didn't give you any fraction problems. I didn't give you any problems where, you know, even your answer was a fraction, did I? Okay, it's a pretty simple quiz. Should be able to get that done, and it should help your grade, I hope. Okay, so now, let's start talking about more complicated equations. You know all of this stuff, okay? You know how to remove parentheses. How do we get rid of parentheses? What property do we use?
Distributed.
Distributive property. You've been doing that, okay? You know how to combine like terms, don't you? Okay. Now we just kind of need to talk about, you know, what happens if you have a variable on both sides? You know, and we need to put all this together into a full, real equation. So let's just start with this. How is this different from what you've seen before?
Variable on both sides.
Variable on both sides.
Add the variable.
Okay? Now, we've got to start going down this list. See the exploding brain? You've got to get it in your brain that every time you look at an equation, you start thinking, are there parentheses I need to get rid of? Are there any parentheses here we need to get rid of? Okay. Are there any like terms? Now, this is a tricky one because these two are like terms. But, listen carefully. Okay, this is a big but. The like terms have to be on the same side of the equal sign. That's what we're always talking about when we talk about like terms. So, you look at this side of the equal sign. Are there any like terms? Can I make that simpler? No. Are there any like terms here?
No.
No. Okay. So now, we're down to step 3. Remove the variable from one side. And you really need to do this before you can do step 4. How can you get rid of the constant on the side of the variable if you have the variable on both sides? You don't know which constant to get rid of, do you? Okay? So, I'm even going to write this twice. And we're going to do it.
Wouldn't you
Okay. Wouldn't you like what?
subtract 7 or add 4 to each side?
Okay. Eventually. But first, I don't want x's on both sides of the equal sign. Okay? See, I don't, if I get rid of the constant, that would be the -4 or the 7. The constant on the side of the variable, well, they're both on the side of the variable. Which one do you get rid of?
Whichever one you choose.
No, you don't know yet. We need to get rid of the variable from one side. So, remember, 3 times x and 5 times x, they're just numbers. You know, let's say x is a 4. Well, then that's a 12 and that's a 20. They're just numbers. We can get rid of them, okay? We can remove them from one side of the equal sign. So, here's an example. You guys probably all would say, let's get rid of the 5x, because you like the variable on the left. So, how could we get rid of the 5 times x? Remember, it's just a number. Yeah. Now, yeah, I have to subtract 5 times x, whatever that is. Okay? And I'm subtracting it from both sides of the equal sign, so will it still be equal? Right? I put a big add subtract line here. Why did I write subtract 5x underneath the 3x and not underneath the -4?
Because it's not like term.
Yeah, like terms. I can put these two together. So I end up with -2x, subtract 4, and what do these add up to? 0 equals 7. Okay? Now can we get rid of the constant that is on the side of the variable?
Yes.
Yeah, see now we know we got to get rid of this -4, don't we? So we can add 4 to both sides. There you go. So we have a new equation again. So this is back to something we've done before. Equals 11. And then what? Divide by -2. So that this gives me +1 times x. And let's put the negative in the top of that fraction and say -11/2. So that's one way you can do it. Okay? Now, I probably wouldn't do it this way. I don't care if the variable is on the left or the right. It makes no difference to me whatsoever. Here's what I kind of don't like to do. I don't really like to have to divide by a negative if I don't have to. So I might think a little bit ahead and say, you know what? I am going to subtract 3x from both sides. Now, am I removing the variable from one side of the equation this way? Yes. Okay, it's your choice. You can get rid of the variable from either side. Doesn't matter. And it's still going to work. What do these add up to? 0. So I have a new equation. -4 equals 2x plus 7. Now what's the constant on the side of the variable? The 7. So I need to subtract 7 from both sides. So we have -11 equals 2 times x.
Positive 2 on both sides.
Okay, divide both sides by 2. Does this cancel and give me 1x?
Yep.
1x equals negative 11 over 2. Did I get the same answer?
Yeah.
So, does it matter which side of the equation you get rid of the variable from? No, it's your choice. Now, I don't even know if this is even any easier, but I just wanted to show you both ways, show you that they both work, and it's really your choice how you want to do it. Okay? So, get a piece of paper out.
So like 7.6.
Here's an equation. Okay, so Kirsten, her side of the room, everybody on your side of the room, you're going to get rid of the variable from the left. Get rid of this one. Everybody on Gracie's side of the room, over, you're going to get rid of the variable on the right. Okay? Are we ready? Almost? Okay, here we go. Every time I look at an equation, this is my thought process. Are there parentheses I need to get rid of?
No.
Oh, good. Are there like terms I can add?
Yes.
Are there? Look, are there any like terms here? Are there any like terms there? Oh, good. I don't have to worry about that. Okay, is there a variable on both sides?
Yes.
Yeah, right, let's take care of that. So I think Kirsten's, you're getting rid of this one, right? You guys? So I'm going to add 6 times p to both sides. So that this gives me 0. Whatever negative 6 times p is, if I add positive 6 times p, they're going to add up to 0, aren't they? So we have negative 3 equals 7 times p plus 2. Where'd I get the 7 from?
I think the 1 is 6.
Okay, we're remembering there's a 1 there. Good. Okay. Then I'm going to subtract, this is my constant I'm going to get rid of. I'm going to subtract 2 from both sides. That adds up to 0, right? So we get negative 5 equals 7 times p. And then divide both sides by 7. And you know what? I would, well, never mind. I'm not going to go there yet. So 1 times p equals negative 5/7. Now, did you guys on the other side of the room, did you get the same answer?
Yeah.
What? So no parentheses, no like terms, variable on both sides. Let's get rid of this one. So we subtract 1 times p from both sides. And you can put a 1 there, that's fine. So negative 7 times p, subtract 3, is equal to, let's see, those add up to 0, so we just have 2.
And just add 3.
Okay, now this is the constant we want to get rid of. So now we're going to add 3. Now let me just stop for a second. If you try to get rid of the constant from one side of the equation before you get rid of the variable from one side of the equation, you're going to have a very tough time. Things are not going to work out. Okay? You're just going to have all kinds of grief. So the order that you do it in is going to make things a lot easier. Like I can do it in whatever order I want because I really understand what I'm doing and why I'm doing it. Do you guys really understand what you're doing and why you're doing it yet? No. The order will really help you. Okay? So that's something that's important. So these add up to 0. Negative 7 times p equals 5. And now we need to divide both sides by negative 7. And this is a mistake I see a lot is you guys get to here and then you just divide by 7. You don't divide by negative 7. So we want to remember that we want this to be positive 1 times p. And it equals 5 over negative 7, which we're going to write this way so that we see the negative a little better. Same answer. Didn't matter which side of the equation we got rid of the variable from. It's all good. You okay with this? Okay. Let's go one more step now. So you don't need to take notes on this. Just pay attention. Watch me do a problem. Okay, this one looks a lot worse, doesn't it? Okay? But I take a look at it. I say, okay, are there any parentheses I can get rid of? No. Okay, good. Ooh, yeah, that's a good one. Okay, now, look at the left-hand side of the equation. Are there like terms?
Yes. Yeah.
Okay, so let's make this simpler. Okay? Let's put these two together. What will that give me? Negative 3k. Plus what?
10.
Plus 10. Now, on the other side of the equation, there weren't any like terms, were there? Okay, so it's as simple as it's going to get. Now, we're not using a property of equality here. We're not adding 4k. Sometimes I'll see kids, you'll add 4k here and you'll add 4k here. But then wouldn't I be adding 4k twice to the same side of the equation? Would it be equal anymore? No. If they're on the same side of the equal sign, you can just put them together. This means the same thing, doesn't it? Okay. So now we're down to here. Now, should I subtract 10 from both sides? Should I add 5 to both sides? I could, but what's going to be the most helpful thing? Do I want to get rid of the constant now? I see you shaking your heads. What do I want to get rid of now? One of the variables. Which one do you want to get rid of?
Negative 3.
Why the negative 3k?
Because then it would be a positive.
Because then the coefficient would be positive over here and we won't have to divide by a negative at the end. So you guys are already thinking ahead to the end of the problem, aren't you? Good job. Okay, so I'm just going to add 3 times k to both sides. So these add up to 0, and I get 10 equals 5 times k subtract 5. Now what's the constant that needs to go?
5.
The 5, okay. Could I get rid of the 10 if I wanted to?
Yeah, but it would get you.
Would it be helpful?
No.
No. Okay, so if we add 5 to both sides, that'll be helpful. These add up to 0. Right? Okay. And then we can just divide both sides by 5. And this gives us positive 1 times k equals 3. If we plug that number back in, will it work?
Yes.
Let's see. 3, that's a 3. Plus 3. What's negative 4 times 3?
Negative 12.
Negative 12 plus 7. Let's add this up. 3 plus 3 is 6. Subtract 12.
Negative 6.
Negative 6 plus 7. Okay, is it 1 or negative 1? Hold on a minute. Don't we have negative 6 and positive? Okay, positive 1. Okay, so this is positive 1. Okay, 2 times 3. Subtract 5. 1. Okay, so this number makes the original equation true, doesn't it? Will any other number make the original equation true? No, that's it. In this case 3, that's the only number that is a root of this equation that will satisfy it, that will make it true. That's it. Okay? All right. So, now you're going to do something for me. I'm going to write down an equation, and you're going to not write down the original equation. You're going to do the first step as you write it down. Now, I'm telling you right now, there's not going to be any parentheses. What do you think there might be? Like terms. Okay. So I'm going to write down an equation. This is an n plus 3 plus 2n equals 4n subtract 5 plus n. Okay, so there's no parentheses to worry about, but there are like terms. So when you write it on your paper, do that first step. Combine the like terms on each side of the equal sign. Okay, you got the first step done?
Yeah.
Okay. So stop solving it. I know you guys are like, "Oh yeah, let's finish now." But let's just check and see how that first step went, okay? So, let's see. Did you put the negative 7n and the 2n together?
Yeah.
So isn't that negative 5 times n plus 3? And over here, what's 4n and positive 1n give me? 5n subtract 5? So did everybody get to this point correctly?
Yes.
So if the black is in your book, the blue is what you would write down first. You do a step. You don't have to write down the original equation. Is that all right with everyone? Okay. All right, now finish. I know you were already doing it, so might as well finish it up.
Got that part right.
Good. That's probably the hardest part. No?
Mine just like
You what?
I just like forgot how to do everything.
Did you get rid of the variable from one side now? Now, if you forget what to do, look at the exploding head. There were no parentheses. We combined like terms already. Remove variable from one side. So the poster, you can look at the poster and just kind of go down those steps. And after 2 or 3 days, it's just going to be a natural thing for you to check, each step as you go along. And if you miss one of those steps, you don't do something along the way, you're going to see it. It's just going to make life difficult down the road, okay? Okay, I think it looks like you got it. So just to bug you, because I taught you about making a positive coefficient, so most of you probably added 5 to both sides, didn't you? I'm going to subtract 5 from both sides, just to show you that you get the same thing. So in mine, I get this variable on the right-hand side to cancel out, and I get negative 10 and plus 3 equals. Now, see that negative right there? That is super easy to forget. We forget to bring that negative down with the number. All right? So most of you probably have 3 equals positive 10, subtract 5, right? Let's see now. I'm going to subtract 3 from both sides. So negative 10n equals negative 8. And then I'm going to divide by negative 10 so that I get a positive 1 times n. What's negative divided by negative? Okay, so my answer is positive, and I'm just going to reduce the fraction, say 4/5. What do you think? Feeling okay about this? All right, so we're going to do a little bit more practice and then we'll get on with the assignment.